Hej,
Hej.
hej. Przepraszam za minutkę spóźnienia, ale tutaj się jeszcze organizuję w innym miejscu niż na nasze czwartkowe kole. Po polsku możemy mówić?
Wiem, że Nazin była, ale
Hej Nazin. You're
ale
on
chyba się
mute.
przed chwilą
If...
wyciszyła.
Hi, we are already live right now.
Okay, so good, I guess.
Yep.
Perfect.
But we kick off at 2 o'clock sharp.
Yes.
Right?
Yes, that's
Okay.
why we can, because I wanted to send the link.
Right.
So
Yeah,
we can just go
good
on.
idea.
Yeah,
Good
we can
idea.
just go on mute.
Right now,
Yes, please.
I have a few questions.
Sure, go ahead.
So you will change slides in the background while I'm doing the intro, right?
Yes.
Okie dokes. And the last question, the few certain questions from Justina, are you going to type them into a chat box?
Yes, Adam, I will, but this is all being recorded live and will be available for eternity.
Right.
So can we just like move to chat?
Sure.
Cool. Thanks.
Sorry for this. Uh, Good day. It looks like the folks are logging in. We are going to have quite an audience today, which makes us very proud. My name is Adam Sadowski from Smart for Aviation, and I am very happy to be here today. On behalf of Aviation Hub community, I would like to warmly welcome you all on the very first Aviation Hub webinar. The Hub is a community built upon enthusiasm, knowledge, and experience in the field of aviation. It was founded in November 2019 by Invest in Pomerania, Boeing, Gdańsk Airport, and Smart for Aviation. We are expanding and have new partnership relationships established since. Very recently, Lufthansa System has joined the community. Aviation Hub is a regional cluster of aviation-related companies in Pomerania. We aim at promoting the domain on both ends, technical and business. Currently, aviation-related companies in the region employ around 1.5 thousand of people, and the aim is to grow. Today, Justina has something amazing to share. She will take you on a trip much closer to the North Pole and will excite you with her own experience in a combination of aviation and science. Enjoy it and feel free to raise questions during the presentation. There will be a time slot for Q&A session afterwards. So whenever you feel like asking for more, just use that chat box and put there your questions. Justina, take us on board.
Hi, hello. Can I'm now I'm live, I think. Everything is set up. Hi, hello everybody. I'm happy you joined me this Friday afternoon for this webinar, and it is a huge pleasure to kickstart events leading up to Aviation Hub conference in the fall. I decided to go today with something a bit lighthearted and with something which hopefully will pique your interest in science and flying. Those topics are I'm really passionate about those topics, and I hope this hour will be enough, even if it's gonna allow for only a teaser of this topic, but I think it's gonna be enough to spark some interest in this information for you. So we will try to look at this topic from a scientific point of view. We will talk a bit about issues that might occur during airborne research, some predictions, and of course, about aircraft use as a tool during scientific flights. Let us start with this. Frankly, from what I saw in publications, there is really not a type which isn't used. We will have examples from every machinery type, starting with drones like Hex H2O, which is a waterproof hexacopter, Splash Drone, which is a classically looking quadricopter, Polar Fox UAV, which can be launched by a bungee, all used for marine mammal observations. Then we also have classical piston aircrafts with Cessna on top, helicopters such as Bells, even the 47 one, and MBB, and classical airplanes we know from civil and cargo operations, which can serve as flying laboratories, and I will also talk about today. And in the end, we also have something which is called high altitude planes, which development seeks for operations above flight level 600, so above the stratosphere. So practically, we can use every machinery type to fly for scientific reasons, even the paragliders, because we do have scientific research such as characteristic of injuries caused by paragliding accidents. So you see the paragliders in this case as a tool is really, really needed. I would like you to think during this presentation to think about a bit of those points I have right now prepared for you, to think and pay attention to expenses, logistic, crew, noise pollution, weather, and methodology I'm going to talk about. And especially methodology. It is an interesting point. Ideally, for every research, we would like to have 3 repetitions of sample to get the mean values. For experimental science, it's a really no-go. To even think about something less than 3 repetitions of 3 different setups with 3 repetitions of controlled sample. So that's quite a lot. But how does it look? How does it look like with flying? It's not ideal. It's a bit similar to my field of study, which is marine biology. I study something called zooplankton, which in short is just a small animals which cannot oppose the water masses. That means that my methodology is just to put the net into the water and do it 3 times. That would be ideal. But you can imagine that if I'm on the ship and I'm putting the net into water, I can't do it 3 times on exactly the same conditions, because every time the ship will move, every time the water masses will move, it's not the ideal sample. It's not the ideal repetition. The same result we'll have in airborne studies. It's simply too many factors to have in mind to achieve the same conditions sample after samples. That, however, that does not mean that we cannot try. And in the end, this is really fascinating. Methodology of such research is still needs to be repeatable for somebody in the future, because somebody needs to be able to check us if our research is correct and if our research is possible to do in the future. So you will see here that there are many examples in literature that publish a guidance and really a methodology study which is used for some specific kind of research, such as the development of practical guidelines for aircraft operations near concentrations of birds in Antarctica. This is something really which is a bit of separate kind of study, but really broadly for just a methodology planning. Usually, for example, for animal observations, surveys are generally flown in small aircrafts, and they need a set up altitude and set up speed along transit style flight paths. And those flight paths are also designed specifically. They could be the observer, which is in the plane, can look out for animals within their reach. So they can just look on the horizon and see, okay, I see some animals in there. But there could be also a specific path that plane is taking. So the observer should be or could just look at the 300 meters of one side of the plane and the other side of the plane. So it really depends on the kind of study that that researchers are pursuing. But as you can see, there's many factors that scientists need to take into consideration to even prepare such studies. And really, the consideration of all of it can be a pain in the brain, let's say. So we see also the rise of specialized businesses to facilitate urban research. So it's not only a science, it's not only aviation, but it also can be a business startup. To avoid thinking about cost of fuel, plane, pilot, ground handling, or even just logistics, if you have enough amount of money, it's possible to simply ask a company to help with all the preparations. And the planning needs to be especially good because in most cases, scientific research is based on acquiring money from grants. And if the planning for the scientific research is bad, you will just not get the grant for you. So as you see, we do have companies specialized in scientific flying, and the one I present you on the left, this, for example, this company has a team of PhDs, science pilots, technicians, statisticians, which they are practically able to provide the research for you. They are specializing in carbon dioxide emission, air quality, or climate changes. And on the right, you can see a team which is doing carbon pollution research all over the world. And as a tool, they are just using Slovakian ultralight aircraft. So really everything is possible. But okay, let us go through some examples for today. Some examples of research conducted recently and a bit years earlier. I will start with this. And I will mainly focus during this presentation on environmental science because it's simply easier for me to cope with. I must say, when I prepared the slide, I did not think through the pain of speaking about dugongs in English, and I will probably butcher the name of these animals a lot. But dugong studies. Dugongs are mammals from the same order as manatee, so you probably know them by name as sirens or even as sea cows. In this specific example of study I brought here, a drone was used. So this also gives me a good base to talk about pros and cons of unmanned aircraft systems. And I will be using this name as UAS or UAV, so unmanned aircraft vehicles. Or probably just simpler, I will tell about drones. In this case, scientific team used Scan Eagle UAV, which is manufactured by Boeing and in situ company. This specific UAV has a relatively large range and long endurance. It can start from pneumatic catapult, which is really interesting, and lands with the use of line on a crane, and you can see it here on the left. It's able to fly for a really long time. It reaches about 20 hours of flight with a speed of mean speed of 90 kilometers per hour. I believe the high speed of this drone is about double of that. And of course, when you see in this picture, you don't think about science immediately. You think about the use of the drone for military purposes, and this is right because the specific drone is also used by U.S. Marine Corps, U.S. Navy, and we also have couple of them in Poland. Anyway, drone aside. For this specific research, it was mounted with a digital SLR camera and it was flew over Shark Bay in Australia. And during such flight, they were able to do 10 transects with area about 1 kilometer square and the area which was frequently used by dugongs. And the drone was flown at 500 feet, 750 feet, and 1,000 feet, if I remember correctly. During such flights, some photographs, of course, were captured. And what is specific about capturing such photographs is that they should have some overlap. So in this case, they used about 10% of overlap between pictures to don't have any gaps in the coverage of the drone. Of course, at those photographs, additionally, some other mammals were noticed. So it's good to have such a knowledge that in the area of occurrence of dugongs, we don't have only them, but you also have dolphins or other whales. But what was the biggest achievement of the study is the sheer amount of images they were able to take with this drone. It was about more than 6,000 of images, and they were able to count 600 dugongs in this area. The conclusion I was interested about in the study was that the researchers concluded that the use of drone in this case was not only more cost effective, not only easier in case of logistics, but it was also safer. And the safer thing is really something that's going to continue, I think, in the future in case of the use of the drones. Because in scientific research over the sea, you need to take into consideration the state of the sea. For some cases, if the waves are high, you cannot fly the helicopters. You cannot go low enough with helicopter to capture a good picture because you will not be simply allowed to fly in such conditions. But with drones, if the conditions will go bad and you will fly the drone too low, if you lose the drone, you lose only the drone. You don't have any casualties. So this is something really interesting as a conclusion to this study. Such conclusions overall, as in this research, are common, are really common denominator for many UAV studies. Besides using especially really special drone like in here, the most UAV we have, the most drones are usually cheap, something between 1,000 and a couple of thousand zlotys. So basically scientists for local purposes, for local research, can just buy a normal drone, equip it with camera and go. It would be perfect for some short flights like 20, 30 minutes and range of a couple of kilometers. This way is also used to not only study marine mammals, but also to study bird nesting sites, to count birds, and even to count people on the events. So as you can see, the use of the drones is really popular in the science, and it's such popular that it's also a topic of many other articles. So as in here, are unmanned aircraft system the future of wildlife monitoring? And probably the answer is yes. The answer, however, slightly changes if we do think about covering of the more vast areas. There, with the dugongs, we had a small local area, a bay, but if you think about a savanna or some larger area we need to cover, it's getting to be a problematic with drones because the specialized one are expensive and the small one are enough to cover the whole area. So in this case of elephant observations, it was really important to cover a huge land. Why? Illegal wildlife trade and its growth is a key driver of biodiversity loss, especially in areas such as Africa. It is a common knowledge that the poaching for ivory has driven decline in African elephant populations, and it's really important to have this population saved because we're lacking of those animals. And this was a specifically problem for southern Tanzania, because it has a specific ecosystem which is called, I believe, I'm almost sure about the pronunciation, Ea Harungwa ecosystem. And this is the place of one of the heaviest poaching area in Tanzania. So researchers needed to cover savanna of over 40,000 kilometers square of habitat for those elephants. It's not possible to do with a drone, with a normal classical civil use drone. In brief, the surveys here were done from Cessna plane. Observation strip was established as 150 meters on the right of the plane and on the left of the plane. So 300 meters overall. And it was really important for a plane to flew at specific height. It was about 100 meters above ground level, because the way they measured this 150 meters from the wings of the plane was that they put the road on the wings, and by that, if the plane was at the specific height, the observers could see, okay, if I see the image between the wing and the road, it's this and this distance. So it was done that way. During those surveys, they got really interesting conclusion. You can see here on the map that the blue areas are the ones that have the live elephants observed, and the red ones are the carcasses of elephants. What was interested in the results of this research, that the live elephants were mainly spotted in the areas where the rangers worked. So in Africa, it's a habit for many countries to have rangers to protect wild animals such as rhinos and elephants and giraffes. So it was really good knowledge for the rangers to know that in the places they are able to be, the elephants are saved. The problem gets to the places when the rangers couldn't go, or when the wet season was on, because then the work of the rangers is also harder. And the most of carcasses of elephants were spotted in this time and in the area when the rangers were absent. So having those information in future, rangers probably could be more available for the elephants and could go faster in the areas when the poaching is really in high. Similar observations also will be done for example, for lodging in Amazonian forest. But having these big animals out of the way, having elephants out of the way, I also found something interesting. You can actually research monarch butterflies from the air. Monarch butterflies, so something really, really small in comparison to elephants, are known to form a huge aggregations in the mountains of central Mexico. However, until 1975, the researchers really didn't know where exactly those aggregations are. Only later, some researchers provided updates in the matter, but still without specific locations. In general, colonies could be found in high elevations where the butterflies aggregate in clusters, principally on the oimel field trees. And the specific area with optimal conditions for the butterflies is about 500 kilometers square. But this specific area with perfect conditions for butterflies is also placed in the region which is about 10,000 kilometers square. So you can imagine that it would be not possible to do this research on foot. They needed something in the air. The first idea was to use satellites. The butterflies should be visible from also satellite imagery, because where they're opening their wings, they have this kind of brownish reddish hue. So it should be visible from the satellite imagery. But you see, there was a problem with that. To butterflies to have their wings open, they needed to have a body temperature of 16 degrees Celsius. During the winter time, when this research was done, this temperature could be available for butterflies only around midday. So it was about 12 o'clock. And this happened that satellite path was done this way, that all satellite images were taken at 10:30. So it was simply too early for butterflies to even move their wings a bit. So the researchers needed to use the plane approach. And they did. They used, as I show you here, Cessna, and they used MAU aircraft. So again, small aircraft. Um, the planes flew from 80 to 200 kilometers per hour and could be airborne about 3 hours at a time. And as they were highly maneuverable, they really could scan the forest canopy at slow speeds. In the end, this is something amazing. Researchers were able to cover even 62% of targeted area. And 62% in this case is not small amount. It's really practical. It's really high amount. And how those animals were spotted? Well, on the left, you can see on the forest the kind of brownish hue. Yeah, this is a colony of butterflies. And the picture below shows you specific individuals of butterflies which were spotted from the air. And what I'm even telling that 62% of targeted area is a big one. It is, because there are some limitations to such surveys. And in case of these studies, it was weather and terrain, and due to terrain, turbulences. You can see on the map on the right that there is on the right lower corner a volcano. And with the blue color, it's target zone in here, and with red color, it's target zone observed. And you can see the main blue color is left around the volcano. And it was a problem because there were huge downwinds from volcano to Luka, and it was simply not safe to go such close to the volcano with a plane. So even with that coverage, even with the terrain issues, even with the weather issues, because the weather not only needed to be nice for flying, but also needed to be perfect for butterflies to operate their wings. So even with that, they were able to found that for such colonies, it could be even 50 million butterflies per hectare. So this is quite a bit. And for my favorite example of small planes used in science, I present you the example of Eyjafjallajökull. Yeah, the name is pretty hard. I practiced. I think we all remember 2010, spring of 2010, when the eruption happened. Almost whole Europe air transport was grounded, and as we practically didn't have any regulations helping us to decide what size of particles in the air is okay for most of the planes. Such eruption was, however, a brilliant event from scientific perspective. Piston motor-driven airplanes, so classical small ones, are safer than jet engine aircraft to fly in ash plumes because, and him I'm gonna quote, so I'm going to focus. It's safer because the air filter of the piston motor can protect the engine from the ash, and the piston motor is operating at much lower temperature than a jet engine, thus minimizing the effect of ash melting in the engine. So off they went. In here in particular, it was Cessna 206. Scientists were able to fly close to warning zone, 50 kilometers from the plums in the Iceland. And they also managed to research the air above the Germany. And thanks to this, they were able to use something called optical particle counters. And in the end, they also used and checked the air filter of the aircraft. This helped a lot because this also helped establish the size of the particles of ash and plummets that we can expect in the air in case of next eruption. And in the end, for EFR flights, for cargo, for civil, for commercial flights, it provided the data for regulations about jet engine particle minima in the air. So I think this is pretty cool for a small Cessna. But enough about the small airplanes. I have a bias because I'm working in the VFR field, but also big planes, of course, matter in the science as well. In this case, I'm talking about filling the gap in satellite data in polar airborne observations, specifically about Arctic, because it's hard to get good and full satellite data for ice coverage in polar regions. Arctic in specifically, it's difficult because it has a really thick cloud cover. The clouds sit low, and the amount of cloudy days could probably make UK blush. So to fill those satellite data, airborne operations were needed. And for this purpose, NASA is using planes like DC-8 or P-3B, which are equipped in such a way to perform even about 40 experiments at one time. Thanks to this, it is possible to research atmospheric chemistry, meteorology, hydrology, climatology, everything at once. For this specific study, the goal was to use airborne laser altimetry to monitor rapidly changing areas of ice sheets, so glaciers and sea ice. A secondary goal was to acquire ice-penetrating radar data to map the bedrock of topography under the ice sheet. And what is cool about this study is that all the results are available for us on National Snow and Ice Data Center. So you can practically go and download the data and use them for your own scientific environmental background if needed. So this is really important to have such data. And for this specific data, it's really important to have them continuously, because then we can observe a trend in the ice change in the polar regions. And as we know, the problems with climate changes and the problems with ice concentrations there are really, really big right now. There are practically hundreds of examples, even if the field of just environmental studies. The ways that the science is using aviation as its tool is it's really from A to Z. We can observe mammals, mother and her calf in the first study in here. We can observe from the air the relationship that the mother and calf have, how they act between each other. We can develop the use of high altitude, long endurance airships to have a long areas, a long time of coast guarding. To spy, we're also using the planes for that reason. And we also can see with the use of airplanes how our evolving world is influencing Mother Nature. And the example on the right, with the rise of popularity of aviation in tourism, the noise level is getting higher and higher, and it does influence, for example, herds of sheep. And in this specific studies, they flew to see how the ships react to the being overflown by helicopters and airplanes, and how the stress of ships is influencing the wool production. So those studies were done in Canada. This is really amazing what we can even think of about studying from the air. And okay, what I'm even talking about it, why I started to be interested in the aviation, why I love the connection of aviation in science so much. Because of that. By education, I'm an oceanographer with the specialization in polar zooplankton. And thanks to that, I was able to participate in a couple of research, in a couple of polar cruises. But I must say it was this one, the cruise in 2018 on board of research vessel Polarstern, that hit me and started aviation journey for me. And here I am. This is the red arrow right there. In a minute, I will tell you more about the research I was able to observe on this ship. But to even talk about flying in polar regions, I just need to say a bit about the basics. Because it is different than on normal latitudes. Antarctic is a specific continent. It does not belong to anybody, and all activities are regulated by something called Antarctic Treaty. To be a signatory with the vote of rights about the Antarctic, the country needs to have a whole year-round scientific station on the continent. And for example, Poland is one of them. So there's about, I believe there's 29 nations that do have vote rights right now. The treaty regulates practically everything. It was signed in the 59, in 1959. And the most important things that this treaty regulates is that all scientific research which is done should be published, should be available for everybody, and that also regulates that all actions taken during the on the continent need to be peaceful. How is it? It's a different matter, but for now, let's say that's enough. And this is how it works. Antarctic is the It's not the easiest place for aviation, but it does have its aerodromes. They are pretty strange. Mind, they are not a classic ones. They move. The one on the left, this is example of Wilkins Aerodrome, and this aerodrome is based on the glacier. So the glacier moves and the aerodrome moves about 12 meters a year, and it also rotates as the glacier is moving underneath it. And flying there is really interesting. It's hard, and it's mostly done by military aircraft, so such as Hercules, for example. So you see, there can be a military operations there. They just need to be peaceful. Anyway, flying by military planes to Antarctica is not the only way of getting there. You can also get there with tourist flights, but it is hell of expensive. It's about 25 to 75,000 of dollars per person. And the flying is risky because of the changing weather. You of course know that temperature on Antarctica is really, really low. It can change rapidly, and the gusts of winds are really rapid. And it's also tricky to fly there because the weather is changing so much. It can close any traffic really, really fast. In here, we just have a simple example of NOTAM, where it says clearly that aerodrome is limited to emergency, and it is because of weather changes. The specific NOTAM is for American McMurdo Station, which have one of the largest aerodromes in there. Okay, so back to me and the research I was able to observe. For me, the possibility to even observe scientific research there, to observe the work of the pilots, and I just need to say their names, Jan Kędzia and Harold Jager, brilliant guys, really brilliant guys. It was something quite spectacular for me. 10-year-old me, who dreamt about being helicopter pilot, was just delighted. So I was able to observe the work of Helena Herr on the left and Sasha Vikerat on the right, which specialize in whales observations. Their previous work established that there is a lot of fin whales getting back in the Antarctic Peninsula region. And as you know, the whaling in the 60s and 70s was a problem, and even earlier before that. So the population of whales was really in decline for a lot of years. Right now, we see the increase of the population, of the numbers in their population, but we don't have full data yet. So as they observe the fin whales getting back to Antarctic Peninsula region, so the Western Antarctica, that was the reason why they got the grant and they got the research on the expedition on the board of Polarstern. They tried during this expedition to fight the huge aggregation of fin whales. They worked with 2 helicopters because one of them needed to be a backup all the time. They flew at about 80 to 90 knots at altitude of 600 feet and covered in one flight the track line of more than 100 nautical miles. During such flight, position and distance of the distance to the track line of the animals was noted, and if the animal could not be identified instantly, the helicopter, of course, was able to hover or to go in the specific direction to track the animal down and to see what it is. I was actually amazed about the skill of the observers. There was a pilot, 2 observers, and 1 more person I will tell you about in a minute, because they not only were able to, of course, identify the animals based on their shape and length, but they were also able to identify them based on the shape of the water dust coming out of the whale's nostrils. So that's something really just amazing. As a result, they were able to spot a lot of them. They were able to spot fin whales, humpbacks, southern right whales, and so here we have fin whales, humpbacks, southern right whale, minke whale, killer whale, and southern bottlenose whale. As you can see here on track, there was a lot of points to do for a ship, and those yellow points are the points that we should do as a ship overall, and that black line is something that we did. So you can see discrepancy there. And here are the tracks of the helicopters. And I must say this is pretty amazing because in comparison to my work, what did I did on the ship, I worked for about 600 hours, while they were about 70 hours in the air. But this is a lot for flying in Antarctica. You can see that um, for a recent order ship, we didn't do a whole plan. So for them to do actually a lot of their plan is it's really amazing because of course the weather in Antarctica is really, really tough. What is more, every flight they took, they had company, but it was at the end. But for the rest of flights, it was a pilot, two scientists, and camera operator, a very specific camera, as you can see in here. And what was interesting that the door to the helicopter were all the time open, so they were freezing their bottoms up there. Um, the camera was really specific, and it was expensive camera because it was used to capture images for BBC Seven Worlds, One Planet series, with its first episode about being about Antarctica. So if you want to see that we captured one of the largest fin whales aggregations captured on the camera, you should see the episode from this BBC series. And of course, the BBC series is narrated by David Attenborough, so it's just a pleasure to watch. So as I can see here, this is a couple of my images from the air, and I bet you thought about what it's in here, what is on the ice in here. And this is just a penguin poop. That's something that you will not see from the board of the ship. That's something you will see from the air. This is just a simple ice floe that the penguins used as a taxi to move, and they left something behind them. So that's something that you can see from the helicopter. Myself, I participated in the cruise at 2018. In 2020, I should board another vessel and cruise to Antarctic one more time with the same researchers. But of course, we know what happened. Pandemic happened and the cruise got canceled. I think it was one day before we boarded the planes. And for scientific community, and of course for aviation community, already at the beginning of the pandemic, we started to talk about the impact of it on different branches of our lives. Granted, we then we weren't sure how vast this impact will be, but to be frank, I don't think we are still sure about it until this day. Many projects were needed to be put on hold due to travel bans that caused a lot of critical data and monitoring opportunities to be lost. Some people were stuck in Antarctica. They couldn't go back home because of the travel bans. That was really, really interesting time, let's say. But also 2020, due to pandemic, happened to be one of the most interesting years in case of environmental response, at least from scientific perspective, because the use of the word interesting would be really a strange idea in aviation. Already in April 2020, we started to see first signs of pandemic changing the environment. First deers, dolphins in Venezia, so something really specific. And also, what is strange that COVID-19 pandemic arrived at the time of significant biodiversity loss. The loss of biodiversity over the last century has been so grave that many biologists were thinking about calling it the sixth extinctions. And the fifth one is about dinosaurs. So that shows you the big problem with the diversity loss. The influence, as I said, was big. There were a couple of problems here and there. There was a completely different problem in Europe, in Asia, in Northern America. For example, in South America, the problem of lack of aircraft movements was that there was an increase of illegal logging in Amazonian forest. Because something that we should think about is that every plane that's going anywhere and any communication from pilots in the air, giving us also the examples and giving them are giving us also the informations about fires, about lodging, about anything important and extraordinary. So the lack of this movement, the lack of observations from the air, both from commercial flights and civil flights, really stopped all those environmental reports. And for scientific flights, it was also a hard year, and it still is. Many long-term research was stopped. The carbon pollution research project I told about in the beginning is postponed already twice. They started the project in 2012. Now they will have 2-year gap. It's really big gap for that such kind of project. Conferences suffered as well as without the exchange of knowledge between the researchers. It's also hard to start another researcher, to start another grants to exchange the ideas. In this regard, really interesting was a project Mosaic, and you can see this here on the right. The project, I think this is one of the biggest projects I ever noticed in case of environmental science for me. It was a huge expedition. It was prepared for by 20 nations. The expedition's operating costs alone were roughly about 200,000 euros per day. And the idea of the expedition was to get the ship, the Polar Stern ship, so the one you saw from my pictures, to stuck it in the air as far north as you can in the Arctic, so North Pole, and to get trapped for a year. And they did that. Of course, as you can imagine, in case of such expedition, the aviation support is really, really important. Airborne research was also a huge part of these expeditions. They had about, I believe, 6 projects that needed the airborne research part. I believe one of them was called impact of low-level clouds and surface conditions on Arctic atmospheric boundary layer turbulence and radiation, if I remember correctly. This is really specific for this expedition, because what is interesting that the pandemic both jeopardized this expedition and, in some strange coincidence, also allowed those airborne research to still proceed. There was a time on this expedition, and I know this for a friend of mine, the pilot who was there, that they were stuck so badly that they didn't know what to do for a moment. The crew change could not happen because of the lockdowns. Pilots should be there, originally pilots should be there for 2-3 months and then change with the next pilots. But my friend was left there for 9 months. There were mental issues, of course, on board, because not everybody was prepared for such long distance and some long endurance of the expedition. So there are really, really, really many issues, but they were stuck and they were in this kind of happy bubble without COVID right there. So they were still able to continue all their research. As of now, reports that we have are scarce, and we're still learning about the impact of COVID on, of course, flying, of course, science, but the company of both. So we still learn about the influence of COVID on scientific flying. We know for sure some points. We know that during lockdown, we have photographs which will be part of social science history forever, such as empty Times Square, empty mosques, and huge graveyards. We do have increase in waste. We do have reduction in waste recycling. We do have increase in plastic waste. We do have a lot of one-time wraps and gloves and mask trash now in the oceans, for example. But something we also got is clear skies. We also got better air quality. We got reduced carbon emissions and cleaner breathing air. And some of the those are only some of the consequences of the lockdown. Surprisingly, also research previously made only for aviation purposes are able now to help in understanding the changes in COVID patients. Majority of them, of course, deals with signs of respiratory distress, and such distress has been already studied for aviation, has already been studied because of the decompression to high altitude can cause severe hypoxemia. So in short, results of aviation-based research in case of hypoxia influence on health of pilots, for example, help to identify presumable problems in COVID patients. So this is a link I would never think about. So aviation science helping them, the researchers in helping COVID patients. Um, what now? What will happen next? How the scientific world will wake up after the pandemic pause? How the projects will start up? For example, how my cruise will go on? We do not know. It's hard to tell. But one thing I'm really, really sure that meetings like this, webinars, conferences, talking about matter of science and linking it with aviation, talking about COVID influence on both of them, this will really help us to understand this phenomenon, and maybe will spark a couple of new and bright ideas. And I think with that, with the silver lining, thank you for so much for joining me today. I hope you have had a bit of fun and got a bit of new information. If you are interested in more, I will welcome any questions. I hope for some I will be able to answer. And I'm really, really thank you for listening. Thank you.
Well, it was really something, Justina. I do appreciate that a lot. And in fact, we have a few questions from the audience. So why don't I pick up just the very first one on the top? The question from Alicia. How did you end up with doing your research and what expertise it requires to be on the team?
So for my research, I ended up on the ship, on a couple of ships, because I choose this polar field of studies, and there's not many people in Poland that specialize in Antarctic krill. Those are small shrimps-like animals, and this is why I get the chance to go on the polar stern. And there's a link between those small animals and the whales, because the whales are eating those small animals I study. This gives me opportunity to work with Helena in Sasha and to learn about their airborne studies. And this was also the reason I should go last year on next expedition to study both the whales and those small shrimps of mine. So that was the reason I got there. To be also in such crew, I think the more interesting part will be how to get to the flying crew. You probably in this case would need be really, really, really specialized in identifying whales, identifying marine mammals. The information I got from Helena in Sasha, because I specifically talked about them, about this with them. Um, it was that they do prefer do it alone because they have this vast experience in research. It would be hard for airborne studies to trust some new observers. So that's why if I flew, I flown with them. I hope this answered the question.
Oh, definitely. We got another one from Alicia. I believe you've briefly answered that already, but why don't you elaborate? Are the studies your primary occupation? If not, is working in the aviation industry boosts your research?
Um, Well, it's hard question for me because I'm doing both right now, and my primary work is aviation as an analyst. That's what I'm doing, like 9 to 5 job, and I must say I love that very, very much. But it was the science that helped me to get the interest in aviation. The science I'm doing just in the evenings. But yes, the information I'm getting from aviation perspective, the information I'm getting from this field, I think this helps me in the science as well because I'm meeting amazing people. The pilots I got to know from the cruises will collaborate in the future, probably. So yeah, I think those both fields are helping each other a lot right now.
That's really impressive. We got another one as well. How fast do you think aerial research is evolving, and do you think it will go in the direction of flights like the one during your cruise, or more with the use of drones?
um, Okay, so I know that one because I asked both the pilot and scientists from my expedition about it. Um, they believe that the use of aircrafts in science will go in the direction of drones. But it will start right now in the areas which are easy to go, so on the mainland. So then research such as birds research, dugong research will go in the direction of drones, because it's just simply cheaper. It's easier to get the drones, it's easier to buy them, it's easier to operate them. You don't need a pilot license to do it, you just need to do it and learn about it. But it's gonna be a problem specifically for remote areas such as Antarctic. There, still helicopter studies will be a basics right now, unless the military grade drones will be more available for scientists. But next year's helicopters still in Antarctica, and drones in the mainland. That's the answer I got.
That makes total sense, I would say. And another one from Wojciech. How the work in polar regions is different than in normal latitudes? What is the hardest thing about piloting a heli in polar conditions?
Safety. Of course, I'm knowing this only from the information I got from the pilots, but the safety is really different there, because when you fly in Arctic, so north, you do have a radio, you do have Arctic radio right there. So you do have some kind of safety net around you. But when you're flying in Antarctica specifically, there is nothing. There is no flight information. There is no fear. There is no airspaces right there. So you have a ship and helicopter in case of studies I saw. So something they did, and something which is stressful a lot, because there is no radar coverage, there is no airspaces right there. So something they do, they specifically communicate all the time with the ship. There is like constant 50 minutes communication between the ship and helicopters. And actually, for Polarstern, it was necessary to have the second helicopter all the time on the ship. So if one flew, the other was safely there and was waiting for any alert for the first flying crew. So that's why they had also two pilots. One was on the bridge awaiting any information, and the other one was flying. So I would say the safety and logistics is the hardest part in flying in polar regions.
Yeah, thanks. Thanks for bringing us closer to this. We get another one from Monica. Any Polish airborne research?
Yes. Actually, we had a nice example in Tricity about it. So above Gdynia, there was a plane flying, which did some studies about the thermal leaks. So they studied how much of the warmth is getting out from the plumbing system in Gdynia. So they needed the low temperature for that. So they were flying, I think, in February. So that was a policy research which was done from the airplane, and really local one for us. Also, my friend, which is a co-author of my publication, did the research in Antarctica, but still, as they are Polish researchers, I would say this is a Polish research. They did this flight with UAVs above the penguin sites, so they were able to use to capture the penguins and to count them, because before that they just went on the field and did this by hand. So such examples, for example.
Yeah, it's really good that Poland is growing on that field as well. I believe we have the last question on board. Is hypoxia in high altitudes the same as the oxygen depth drunk syndrome in deep sea diving?
I would probably need to check on that one, because this is out of my safety zone. But yes, I believe I saw some information that also the studies about divers helped COVID patients a lot. But that one I would prefer to check before I will say. But from my knowledge, yes, it's similar problem.
Wow. Wow, it's really impressive. I think we're done with the questions. So, Justina, thanks so much for bringing us a bit closer to the whales and every single thing you've shown us, exceptional landscapes shot from the air. I personally find it amazing and really enjoyed it. So, thank you again, and thank you all for joining us today and following the Aviation Hub activity. We as the community are being very optimistic about the recovery from the pandemic. So stay tuned for the next events planned for the upcoming months of 2021. There are more webinars to attend and grande finale show set up for November, which is the Aviation Hub Conference of 2021. More news to come on that. So stay healthy and therefore more of aviation. Goodbye. We'll stay in touch.
Goodbye.